Rates of reactions. Chemical reaction rate refers to how quickly or slowly a reaction occurs. Factors such as temperature, concentration, and catalyst can affect it. Like mentioned before, the first part is the factors that influence the rate of reactions. And temperature is the average kinetic energy of particles, the surface area, particles that are available to react. Catalyst does not take part in the reaction, but it does speed up the reaction. And concentration, the number of particles in the area, will either be more or less particles. Let's look at each one individually. Temperature. Hypothesis: the greater the temperature, the quicker the reaction. A hypothesis is something that you assume before the investigation is done, and the dependent variable will always be the rate of reaction and the independent, the temperature. To measure the change in temperature, you have to use a thermometer, and to measure if gas is produced, you have to use a gas syringe. And the collision theory states if you increase the temperature, the kinetic energy in the particles increase, thus more collisions per unit time, so the reaction rate increases. Basically, the increase in temperature, increase in reaction rate. These are the graphs for the rate of reactions. So in this one, you can see that this is the reactants and this is the product. And if you're putting onto one graph, like in the middle, and you see where this orange arrow is, it shows the reactant being used and the products being formed at the point where the two graphs meet. And the start of any reaction is fast, but slows down eventually because the reactants are getting used up to form the product. Let's continue. Mass. The greater the mass, the more particles there will be, so more to react, thus a higher reaction rate and more effective collisions per unit time. Concentration. The higher the concentration, the more particles and collide more frequently, thus more effective collisions per unit time, and the reaction rate increases. Catalyst. If a catalyst is present, it speeds up the reaction and lowers the activation energy of the particles, so more particles will have sufficient energy to react, thus the reaction rate increases. You can be by heart these. So, in a test or an exam, this is exactly what you have to write down for your full marks. An endothermic process means breaking of bonds, more energy absorbed than released, so the net energy will be energy absorbed. New bonds are weaker than bonds that are broken, and there's a transfer of heat energy to potential energy. Here's an endothermic graph which you can study and analyze. This is the exothermic process, which is a formation of bonds. More energy is released than absorbed, and new bonds are stronger than bonds broken, and there's a transfer of potential energy to heat. So, this is the opposite of the endothermic graph. The surface area is if it's broken into small pieces, that's more surface area for collisions to occur, more effective collisions per unit time, thus the reaction rate increases. Pressure has to do with only gas. Please keep that in mind and do not make the mistake of putting it with liquids or solids. Molecules are forced closer together, more effective collisions per unit time, so the reaction rate increases. And some more catalyst information. A catalyst does create a different path along which the reactions can take place. It lowers the activation energy and it increases the rate of reaction. It doesn't start a reaction, it doesn't get used up, and it doesn't change the energy of the reactant or the product.